Hello, welcome to the latest in the series of webinars. This series is put together by the Energy, Environment and Sustainability Group at the Institution of Mechanical Engineers. And we aim to shine a light on various areas of sustainability, etc., that our expert speakers are able to open up for you. So today we're going to have Paul Pitcher as our speaker, and he's been in some very fascinating jobs at Airbus, Boeing, the European Space Agency and NASA, and he's currently working on a new satellite delivery platform, which I have to say I'm a bit envious. And he's had a sustainability theme to his work all the way through, and very much an aviation enthusiast. So I will hesitate no longer, but pass you over to Paul for this talk.
Okay, welcome everyone to this webinar. My name's Paul Pitcher. I'm an aerospace engineer. I've got experience across the civil and military aerospace sector. Also a brief foray into naval nuclear defence, and a lot of experience in the space sector as well. Right now I find myself working for Orbex near Inverness in Scotland, and we're at the moment building our prime rocket, which will hopefully be the first rocket to launch from UK soil since Black Arrow in 1957. So it's quite an exciting project at the moment. So my background is aerospace, but I'm also a member of the Energy, Environment and Sustainability Group at the IMechE for a number of years. So I bring a bit of a unique perspective in that sense, in that I'm very much an aerospace enthusiast, but at the same time, I'm a passionate hill walker, and I've got a keen interest in sustainability. So in terms of the webinar and what we're going to be talking about today, just to kind of define the scope, today we're talking about civil air transport, really. There are, of course, important aspects of aerospace, such as military, general aviation, and actually being up in Inverness recently, I saw the Eurofighters coming out of Kinloss. It's an incredible aircraft. So I have a passion for military aviation, but I'm not talking about that at all today. Just really civil air transport, passenger transport. It's worth mentioning as well, noise is a really important topic when it comes to aviation, but just for time today, I'm not really going to touch on the topic of noise, but it's an incredibly important topic. So I just wanted to kind of acknowledge that from the outset. So, okay, in terms of the overall approach today, I thought I wanted to try and come at this from a bit of a new direction. So I liked the idea of looking kind of past, present, and future, because the past and how air transport was many years ago can tell us a lot about, okay, well, what should we look to the future? And got a quote there: "Our future depends on how we understand the past," which I think is attributed to Leonardo da Vinci, but I think it's incorrectly attributed to him. But anyway, yeah, always looking at history gives a lot of insight for the future. So, and obviously at the present, right now, we have the coronavirus impact on the industry. Forbes saying that passenger business is essentially evaporated at this time, which is completely correct. And then obviously the future is that crucially important side of things. So, that's the approach I wanted to take today, is just have a little look at these kind of three different viewpoints, if you like. But having done that, let's define some of the terms. So, thinking about in particular sustainability. So, what does sustainability really mean, and how do we define it? The first definition I've got up there is that's from the Brundtland report. foundational document, really. And it defines sustainable development as development that meets the needs of the present without compromising the ability of future generations to meet their own needs. It's very much asking that question of, what will air transport or transport in general look for my children? And how will it look for my children's children, and so on. I want them to be able to enjoy the world and enjoy air transport in the way that I have been able to. But that might mean air travel looks quite different, or transport in general, the way we have it now and the way we perceive it and need it and want it today, could look quite different in the future. The other quote there is a definition which I really like, which is sustainability can be best defined as the capacity for continuance into the long-term future. There's a number of activities that are sustainable in the short-term future, 3 to 5 years time. But it's when we then look into the long-term, 20, 30 years, that it becomes more challenging. And, thinking about what the world might look like for future generations, for my children, I want to make sure that they have, an ability to enjoy the world as I have been able to enjoy it and see the world. And as I'm approaching this and as I'm saying this, I'm coming with particular spectacles on as I view the topic. So just, to put that out there from the outset, here are some facts and figures that kind of frame the overall context of the webinar and what I'm looking to kind of convey today. So first of all, the World Wildlife Federation now reporting 50% of the world's coral reefs are now bleached due to increased ocean temperature. Will my children be able to enjoy a coral reef? The United Nations, of course, have set the limit of 1.5 degrees C global warming versus pre-industrial levels. And that limit, being beyond that limit, as they say, quote, presents large risks for natural and human ecosystems. And only this week, the WMO have come out and confirmed that we're now at 1.2 degrees C above pre-industrial levels in some data sets, saying that we're past that anyway. So, I'm coming with these things on my mind, and I think it very much colours the perspective, and thinking about sustainability within that mindset is what I'm wanting to explore today. So let's have a look in particular then about what does sustainability not mean? Well, one aspect and the kind of buzz word or the buzz term nowadays is, of course, net zero. And I think generally net zero is referring to carbon dioxide emissions, that the amount that are generated or emitted into the atmosphere are maybe offset somewhere else in such a way that overall there is no net growth of carbon dioxide into the atmosphere. But that's not necessarily sustainability, because that still consumes potentially unrenewable materials. And then we think about the idea of carbon neutral growth or carbon dioxide neutral growth. Is growth in of itself sustainable? So if we just continue as we are, sometimes the technologies just enable the unsustainable path forward. And even beyond that as well, it's not just about climate change or being environmentally responsible. I'm quite aware there may be people listening today who are climate skeptics. The statistics show that there's still a very high proportion of the population, not necessarily believing that humans are generating the temperature rise on the planet. So even if that wasn't a factor, what factors would still remain to make something have the capacity to continue into the long-term future? So what about energy supply for the aircraft? It's clear that we're already past peak oil, fossil fuel supply. What about material supply as well? Scarcity of materials and end of life disposable, these kind of topics. So just asking a few questions and pushing a few buttons there. Before we go on, I wanted to introduce as well this chart on the right hand side, which has been produced by the group in the IMechE, which is it's really a tool. We call it the energy hierarchy, and it's a way to think about transport and your transport system and how to make it more sustainable. And you can see there, of course, priority one has to be minimize demand. If someone is now no longer having to conduct a journey, then they're not consuming the materials, they're not occupying a seat, they're not generating the emissions anymore. So priority one has to be minimize demand. After that, then enabling modal shifts. So perhaps instead of taking an aircraft, you maybe go by a mode of transport that is more sustainable or emits fewer carbon dioxide emissions. Maybe you're choosing to go instead of air, go by rail, or instead of traveling by car to work, cycle to work. These kind of things. Beyond that as well, optimizing system efficiency. So it's well known, of course, that internal combustion engines, reject a lot of heat. So that aspect of, how can we make something more efficient, and then finally increase capacity to increase resilience. That's particularly a factor when it comes to airports, where we have airports which are running at absolute maximum capacity. As soon as you have some kind of event, a weather event, for example, you then go into wasteful behaviors like holding patterns of aircraft, for example. So just introducing that as an overall, all of this is just an overall introduction to the webinar and looking at, okay, how then do we step forward from this place? Past, present, and future is where I'd like to go next in the webinar, which is thinking about, first of all, the past. Then here's a little image of a poster from a while ago. So looking at transport, going back to the 1910s, 1940s, kind of pre-World War II kind of time. Really, flying was not common at all. It was something that was primarily something that was military, and really it'd be road and rail transport. But even then, most families wouldn't own a car. So if you wanted to go on holiday, you would maybe be taking the train to the coast, or jumping on a bus to some popular destination, maybe some nice countryside, or you can see there Dorset, these popular kind of coastal towns. And it wasn't then, till kind of 1960s, 1980s, you had the kind of post-war technology boom with the Boeing 787, which is that's the most popular air transport craft ever built. Its first flight was in 1967. But even then, I was talking to my father about these kind of time periods, and he didn't fly until 1980 when my parents went on their honeymoon, and even then there was still that perception that is it even a safe method of travel? And my father was talking about how they would, the big moment in his childhood was when the family bought a car and they could travel, and it took 3 days for them to travel from Plymouth to Llandudno for their holiday. So it's just I find that all very fascinating, that how transport was viewed, only a generation ago. And then we come to the 2000s, 2010s, when I was growing up, and very much we had the low cost carriers, kind of stripping everything back. And I personally have travelled to Paris for a very small amount of money. But transport in of itself is a derived demand. People are normally travelling to achieve something else. There are very few people who travel just for the sake of traveling, like a railway enthusiast or something, or in my own case, flying for pleasure. So it's always a derived demand, or in the majority of cases. So, what is the reason? Why are people traveling? It's to kind of escape the kind of drab wretchedness of our lives. Let's go somewhere sunny for a time, have a nice holiday. And it's not that long ago that looked quite different. Continuing the past, then, looking at some of the foundations as well. I just wanted to kind of give this picture as well. I am an aerospace enthusiast. Look at this quote from Amelia Earhart. She says, "After midnight, the moon set, and I was alone with the stars. The lure of flying is the lure of beauty, and this is the reason flyers fly." So, this is an IMechE presentation. I'm sure a lot of the people who are dialing in, seeing the title of aviation there, that will be in many ways on the same page as me, that there's just something very magical about flying, and that has to be at least part of it. It's something that is intuitively, well, for me at least, seems impossible. How does something? I watched the Airbus A350 lift off, and that's got a maximum takeoff weight of 575 times 10 to the 3 kilograms, which is the same weight of more than 40 Big Bens. And it's just incredible. It's just incredible, and I really wanted to kind of color the overall message here, in that there's something really special about flight. And I've got here the Article 13 from the United Nations Universal Declaration of Human Rights. It says everyone has the right to freedom of movement. Everyone has the right to leave any country, including his own, and to return to his country. That's my own journey in terms of kind of growing up and seeing air shows. It very much shaped my world, and brought me to where I am today in my career in terms of being in the aerospace industry. So let's now take a little step into the present. Of course, I'm going to start just immediately before the present with some passenger numbers from immediately before the coronavirus. So let's just have a look at. I'm going to present a number of graphs here. So the first graph from kind of before coronavirus. You can see here these are journeys at the UK main airports from from DFT. So this is Heathrow plus Gatwick plus Luton plus Manchester plus Stansted, and no other airports. And this is a departing passenger survey. And you can see there, 2019, only 17% for business. By far the majority is holiday or visiting relatives. By far the majority. Looking at the next slide there as well, another survey. This is a popularly quoted survey. I hear it a lot in the media. This is an Ipsos Mori survey, where it's not necessarily passengers at terminals. It's more just almost in a census kind of an approach. Just kind of 1,000 individuals were surveyed across the nation, and they found that 18 to 24-year-olds are the most likely to fly, and then of those surveyed who said that they do fly, they indicated that 89% of the time this is for leisure purposes, and only 2% of the time would it be usually for business. And a different data set here at the bottom, and with the figure there from the Office of National Statistics. These are number of visits abroad by UK residents in 2019. The top 6 there: Portugal, USA, Greece, Italy, France, and then by far the majority is Spain. So you begin to get the picture of. I mentioned demand reduction. Where is our demand coming from? What is the demand? Well, it's young adults traveling for leisure to Spain is the most common traveler. Now I would say on this slide there are other data sets which show the United States coming much more up this graph. For example, New York. So there are other data sets out there. It's just the data set that I chose for this particular presentation. So the demand is there, and what of how is the demand shaping? And the demand year on year is growth. it is absolutely growth. Looking at this figure that I've given at the bottom, you can see there the orange curve is year-on-year growth. So 2018 versus 2019, you can see there I'm indicating 5% growth. These are ICAO numbers. So it's a situation that is or was up until very pre-pandemic situation set for year-on-year growth. Additionally, it is slightly older numbers here. In 2018, the EU ETS reporting declared that Ryanair is the new coal. So this is all across all industries. CO2 emissions or CO2 equivalent emissions are reported, and of course many coal-fired power stations are being decommissioned for environmental reasons, which has meant they've come down the curve. But actually now Ryanair declaring 9.9 times 10 to the 6 tons of CO2 equivalent, being the 10th largest emitter, allowing the somewhat provocative headline, Ryanair is the new coal. And that's within the context of the EU ETS system, which is to do with offsetting emissions. We have also recently the cheap neutral spoof website. And if you'll forgive me for a brief foray here, the cheap neutral spoof website is for it's a tongue-in-cheek comparison where if someone is not willing to be faithful in their marriage, for example, they can pay money and pay someone else to be faithful in their marriage, so that overall the amount of infidelity in the world is neutral. This being the idea of cheap neutral. Just because you offset something does not necessarily mean that the original activity is ethical. It's a bit of a right-wing comparison there, really. I kind of want to distance myself from that a little bit. But you begin to see, just some of the kind of some of the things that some of the right-wing media are putting out there. So, and then, as I say, the growth continues as well, and it's not just within the UK. Here's the IATA. So this is all air transport operators. This is their traffic growth information, and it's Europe, Africa, Middle East, Asia Pacific, North America, Latin American, Caribbean, all of them almost above 2%, most of them above 4% year-on-year growth. So it's something that up until very recently was set for not just slow growth but significant growth. And then more recent past, we have this curve here, which is again this is from IATA, and you can see there the pandemic effect, which this is the worst decline in history for the industry. There's never been anything like this before, and you can see the kind of growth moving along there. Again, here's some an image from Eurocontrol. So the main, just to orientate you a little here, the coloured section there in the middle, those are CO2 emissions from flights, comparing 2019 to 2020. You can see the kind of numbers there. Some countries minus 70%, minus 55% would be about normal. And then the overall mean, the average is departing flights down by 54.5%, CO2 emissions down by 56.9%. So, a considerable impact, and leading Forbes to make that statement that passenger business has essentially evaporated. It's worth mentioning that the cargo by air transport is up. So obviously we're maybe ordering more goods or shipping more goods. Maybe people are using certain kind of online delivery type arrangements more frequently. What then of recovery? Here's a graph here from ACI. So they show the decline there. It's the decline. You can see the historic numbers there in blue, and then everything's referenced to the 2019 traffic before the pandemic. You can see it jumps down in a straight line there, which it was such a sudden decline that it is almost straight. It's not perfectly straight. I think there's a little bit of a fudge factor in the curve there, perhaps. but nevertheless, you see the drop down there. They're obviously advertising 36.7%. I think it's actually much lower than that now. So I think it's probably a deeper recovery. But they are estimating between 3 and 5 years to recover. But I think that now will likely be longer in terms of traffic. And you have to understand that recovery is not just a case of jumping back in the aircraft and getting back on. Getting back to where we were before, there's much wastage in terms of, where do I start? So we have many aircraft which have been standing, which will now never return to service. There's some which will just not be returned to service on a cost basis. So that is a waste. Previously usable aircraft now not usable. You have aspects of in terms of flight training for pilots. They have to stay constant and up to date. You have to do a certain takeoff and landing quota, and that's all a cost to the airline, getting them into flight simulators and building back up that familiarity. Maybe spending some time in the jump seat of a cockpit with other pilots. That ramp up of training and just the safety aspect of going from taking an aircraft from a standing position to there's a certain to move from storage to operational status on an aircraft takes a certain procedure, and that has to be followed. And all these things take time and money. You then have in terms of the actual travelers themselves, we have instances where temperature checks on arrival are forcing people into quarantine. You kind of book a holiday, you end up arriving, and then you have to stay in a quarantine for 2 weeks rather than enjoying your holiday. And things like travel and insurance being at the traveler's risk. People asking about, what's the state of the healthcare at my destination? If I do get the virus, what kind of healthcare will I receive? And aspect of being the fear of being close to an infected person on the plane. And of course, earlier we said that young travelers are the most common, and they're most likely to be asymptomatic but still carriers. So it's not just a case of everyone's going to book their holidays and we're going to get straight back to it. It's so multifaceted. One thing that I did like to see was in terms of recovery funding for the airlines. One thing that Air France are doing is the recovery funding that they're receiving is contingent on withdrawal of routes where, for example, a rail journey is available. So this is the idea of building back better. Where the travel time is less than 2.5 hours is the limit that they're putting on it. So if a rail journey is available, Air France, okay, you get your recovery funding, but you have to withdraw these routes. And you begin to see that actually, we could use these somewhat negative circumstances to bring about perhaps what might be an overall reduction in this way of carbon dioxide emissions and energy consumption. So then, what about the future? I have here this is a well-known curve from IATA as well, and this is I have to say it's not a curve I'm particularly keen on. You can see, for example, above the red there, the assumption is growth. The assumption is year-on-year growth will continue until very much the foreseeable future. 2040. Sorry, it's such small text. I tried to blow this image up as much as I could, but it's 2040 is the end of the graph there. So, the anticipation is that we will continue to grow, and that we will offset our growth to achieve carbon neutral growth or carbon dioxide neutral growth. But only recently we've shown that it is the non-CO2 effects which are much more effective in warming the planet. So, of course, aircraft don't just emit CO2. There's also NOx and SOx and contrails and all of these things. And all these things have a certain amount of effective radiative forcing to influence what's happening in the atmosphere to to make an increase in global temperature. And it's been shown that the non-CO2 effects are something like 66% of the overall increase in radiative forcing. So it's it's not just about CO2 emissions at all. And a big part of this curve is offsetting emissions. Sorry, the text is small. Market-based measures. That's the CORSIA program. So the majority is using an offsetting method. So the other parts of the curve here are in red: operational improvements. So that's obviously making flight paths more efficient and ground operations. You then have aircraft technology. And if there's one thing that I've not spoken at all yet that I have to now mention, it is just our incredible aerospace industry. The technological improvements that we have made as members of the IMechE and the Aeronautical Society to tackle this problem of climate change are absolutely incredible. I'm looking at some of the pieces of equipment, and I'll talk about this a bit more in the next slide. I think we have responded so well, and I think we do need to feel immensely proud of how much we have done and are continuing to do to tackle this. And I would have been remiss if I hadn't mentioned that. Of course, the flip side is often more efficient technologies enable the unsustainable behavior, and it's natural for us as engineers to want to solve the problem with technology, but technology is not necessarily all of the solution here, particularly with reference to the transport hierarchy that I mentioned earlier. What then? What other kind of aspects do we need to think about in the future? And touching on the technology, I wanted to spend a bit of time talking about the technological solutions that are out there and being developed, the things that are in the pipeline. Hydrogen is a hydrogen-powered aircraft. I mean, it's something that's still very much in its infancy. Competing demand is likely, but that could be a vector. Electric propulsion as well is something that's coming through. It's still only relatively low capacity. The golden egg here is the 100-seater with 1,000 miles range. That's what we're looking for, and that's not something we're very close to achieving. Sustainable fuels, the oil price and fuel price with respect to fuels, alternative fuels, is really central there. In terms of when it becomes competitive or not. And I personally don't like the term sustainable aviation fuels because sustainability is so wide-reaching. I prefer the Royal Society definition, which is alternative fuels. How sustainable are these really? And they are quite far down the transport hierarchy. We've got there the CO2 capture and storage, which these are kind of R&D projects only at this stage. Although I think a lot of very good work is being done. It's worth saying as well. Some of these things they're highly constrained in terms of energy production. Competing demand for agricultural land, forestry, electricity for synthetic fuels, and fuel is essentially an energy source, and the fuel is to be used in other industries such as road, such as generating electricity. Most of our electricity is still not renewable. There's so much constraint there. And just before I move on, that engine on the right hand side, the Trent XWB. I worked a little bit on the Airbus A350, not on this engine, on the nacelle, and what an incredible piece of engineering. And just to stand next to that is just I think anyone would feel proud to know that we've made this piece of engineering, and it's the most efficient engine now that's ever flown, I believe, and something like 99 or at least above 90% of the materials can be recycled as well, and other companies like Pratt and Whitney are doing very similar projects. So, yeah, just incredible engineering. So, yeah, we've been on a bit of a journey, and just to kind of try and wrap things up a little bit and move on to our question time, and we do welcome any questions. For me, this is an international problem. It really can't be solved at a national level. And that international regulation coming from ICAO, for example, is just not happening quickly enough. Granted that the policy is not straightforward. It's really not straightforward. CORSIA and the carbon offsetting system is a really good start. I know it gets a lot of bad reputation, and there are a lot of kind of pros and cons, but I think it's better than nothing. And I think that is moving in the right direction. But it's just, in terms of the other parts of the transport hierarchy, nowhere near enough is being done. So in terms of air travel, it's always going to be a powerful force for good, we have been very responsive to sustainability, but I think much more emphasis on sustainability itself is needed, not just CO2. The other vectors, such as energy, such as the non-CO2 effects and radiative forcing, and those aspects of the transport hierarchy, which are, these are all things which are down the transport hierarchy. What about demand reduction and modal shift? Those have to be part of the solution. And looking at ourselves, the people of the past got to the coast, and they very much spent their time in the UK, holidaying in the UK. I find that I question myself and ask, what if I, as an aerospace enthusiast, what if I made a decision not to fly again? How would I feel about that? And is that the decision I should be making? Should people be making that decision? I don't know. I would struggle to make that decision, because flying is something that's so important to me. But if it's at the expense of future generations and it's not sustainable, maybe it's time for those for me to make that hard decision. I don't know, but I do believe we have to be responsible for our own use. If you put a crisp packet in the bin and then wind comes along and blows it straight out the bin again, I'm going to go pick up the crisp packet and put it in the bin. You're responsible for your use, for your waste, for your consumption, even after you've actually experienced it. So it's not just a case of me flying and having a holiday. What about the effect that's then had? And we as engineers, we should be the ones who see the future. We understand these aspects of, on the very technical level, of fuel consumption and alternative fuels, and these are all thermodynamic problems in many ways. It's all joules and watts and meters and kilograms. We do understand the problem, and we can't leave it down to the politicians. We have to forge the path. We have to be the ones who see the future, make the path towards it, and then influence the policy to suit the future vision, which makes sense from the engineering standpoint. So I encourage us all, to get our heads around this topic, and do what you can. So good. Well, thank you for listening. I think now we've got a few questions coming through, so let's move across to that.
Oh, thank you very much indeed, Paul. These a very illuminating talk. We have a number of questions that have come through, and if you'd like to have a look at the question list, do feel free to address them as you feel fit.
Okay, can you hear me okay, Michael? Yeah?
I can indeed.
Good. Okay, so let's have a look at the questions here. We have one. It says, a significant difference between aircraft and other means of transport is a lack of tax on fuel. Okay, yeah. Could you expand on the reason for this obvious omission suppressing technique not being used? Yeah, that's an age-old topic. That one, the tax on aviation fuel, because at the moment there isn't any tax on directly on aviation fuel like there is on fossil fuel for road transport, for example. So I think there's a lot to say on that topic. A couple of things. It's baked into history now that it's been really from the foundation of the industry, of the aerospace industry. There has been no tax on fuel, so to now change it would be incredibly challenging. And the important thing to always remember about air transport is it is an international problem. Every problem that we can think of to do with aviation almost is an international problem. So you then have to try and apply this tax in an international way. Otherwise, you get things like, you fill up an aircraft with fuel and pay tax on it in the cheap tax country. You then fly to a country where you can sell it for a lot more. So that's called tankering, where you actually transport fuel. Another thing I would say is, if we're trying to motivate, fewer emissions, for example, the aviation industry, the civil air transport industry, is not a high margin industry. It's a low margin industry, and already the fuel component is a massive component of the costs of an airline. Well over a third of your ticket is just fuel by itself. So to then increase that further, it begins to get into a place where there's economic problems. And finally on that, just in terms of actually motivating sustainable behavior, one of the things I mentioned is alternative fuels. And one of the problems with alternative fuels is they're still not competitive against fossil fuel prices. And what we need to do is actually make them more competitive. And adding a tax onto the fossil fuels it just makes things worse. So that's I guess a very brief response on that one. Okay, let's have a look down the list. So, okay, airships are extremely efficient. What are your thoughts about these not being used? It's funny this has been mentioned. I actually, in one of the early drafts of this presentation, I did actually speak about airships as a technology, and that was on the same slide. I ended up cutting it from the slide deck just for time. I also talked about supersonic technology, both things which are coming through. For example, the supersonic side of things being Boom Aero. They're developing a supersonic aircraft with the headline, "You can fall in love with someone in a different continent." And then what I had in that slide was the Airlander 10, and it's got a 5-day endurance and it can take 18 passengers. And yes, I mean, it is a very efficient method of travel, but it's just the sheer numbers. So, you're talking about 18 passengers, and then the speed as well is much lower. Versus other kind of low altitude aircraft, it's at least half the speed. So there's just in terms of transport being a derived demand where you're trying to achieve something. I mean, I see this as, in terms of pleasure flying, the airship is fantastic, but in terms of an actual mode of transport, it's got its limitations, of course. Okay, let's look down the list here. Other questions. Okay, so how can we continue to enjoy travel around the world and allow those from developing economies to join us while still achieving a sustainable future? The two appear to be in direct conflict. What I would say in that one is just back to that aspect of it's always an international problem. In terms of, I think you're speaking particularly about demand growth there. That has to be something that's done at a global level. So that's at ICAO level, the UN level. where regulation and carbon dioxide offsetting is done at a global level. We can make certain adjustments in our country to our infrastructure. We can make choices to make rail more of a viable method versus air. So for traveling, my common journey is Glasgow to London. Glasgow to London by air is about an hour and 10 minutes of travel time by air. Then by rail, it's more like 4.5 hours. So what can we do to make that more appealing? We also have instances where across to Northern Ireland, to take the ferry there versus flying. My understanding is the ferry is significantly more expensive than flying, whereas the traveling on the ship is much more sustainable. So I think there's things that we can do at home domestically to make the economics line up. We can make our own personal choices, but then to actually look at developing economies and how we can develop together in a sustainable way, it has to be done at the international level. I hope that answers that question okay. So what else have we got here? Do you think that Hyperloop is a viable future competitor? Wow. Well, it's very cool. It's the Hyperloop is at such a low level of technology readiness level as to I don't know quite what to say there. I think the main appeal of air travel, of course, is the distance that you can cover, and the kind of sweet spot is about 250 kilometers or so, where kind of rail and road are starting to get a little bit harder to travel and more tortuous to travel. As a little study in preparation for this presentation, I looked at if everyone's traveling to Spain from the UK by air, what's their alternative? If we're trying to come up with more sustainable alternatives, what is the rail journey from my front door to Alicante, for example? And it's an incredible journey, really, to be honest, by rail. So and the Hyperloop, I don't know so much about it, but I think range is going to be a limitation there if you're trying to peg it as a competitor to air transport. So yeah, but I have to confess a little bit of ignorance on the Hyperloop system and exactly what its capabilities are. Okay. So next question we have here. Can you see how the legislative and regulatory framework for a sustainable system can be brought about? Are you encouraged by the industrial syndicate approaches emerging, such as the small modular reactor solutions and EV recycling, as well as production? Yeah, okay, that's a good one, and very multifaceted comment there. And all these things looking at things such as the circular economy and things, as we put more materials into the aircraft, which, for example, carbon fibers, which can be readily recycled, as opposed to the aircraft graveyards of old. Through pyrolysis, we can actually recover carbon fiber and reuse it. So I am encouraged by that kind of thing, and the small modular reactor side of things. This is the idea of small nuclear reactors at almost a community level, to instead of the massive overhead of the civil engineering of a nuclear reactor that we have right now, where it's quite an incredible site over many acres and incredibly expensive. Well, what about something that's much smaller, much more modular? So these are all very good vectors for generating electricity, and that then paves the way for things like alternative fuels, for example, hydrogen, and hydrogen is a topic which is getting a lot of discussion at the moment, and of course the aim is to generate hydrogen from renewable electricity through electrolysis. And all these bode well for alternative fuels, for the electric aircraft. Yeah, I think these are only going to be good trends. I hope I answered that question okay. I could say more, but I think I'll stop there. Okay. Yeah, we've still got some time. Let's have a look. Okay, if we have one. If the ferry and rail are more expensive, then surely we can reduce demand by taxing the fuel and making flying less economically attractive. Yes, I agree with that, at least in part. I think the comment, maybe I didn't mention this previously, is just that idea of market distortion. So as soon as you bring in a market-based measure, such as a taxation, then you are distorting the market. You know, you're tweaking something artificially in a particular economic direction, and we can do that, yes, at a national level, but that then puts all of our UK operators at a competitive disadvantage to every other country, essentially, unless we can agree on globally on the fuel tax. Then we are going to be at a competitive disadvantage versus other countries. So this is the aspect of it has to be a global solution. You know, as soon as we start thinking, okay, well, what's the UK solution? Then that's when we get into positions of distortion and problems. And hence that's where the CORSIA system, so that's carbon offsetting, a carbon dioxide offsetting system put in place by the ICAO, which I quite like, actually, because it does bring that ticket price increase at a global level to try and balance that up, you know, to try and make essentially, yeah, it's a market distortion, but it's one at a global level. So I guess that's what I would say there. Okay. We have here, when airlines offset their emissions, do they only offset their carbon, or do they also offset the carbon equivalent effects contributing to climate change, e.g. contrails and NOx, etc.? I think there is right now a NOx component to CORSIA, although I could be wrong about that. I'm convinced that that NOx is included somewhere, but the big recent development is that beyond even NOx, things like contrails are coming through as even more significant again, and I'm meaning that with respect to the effective radiative forcing within the atmosphere causing a temperature increase globally. So I have no idea how you're going to create a component of that within the CORSIA system to essentially say, okay, well, you generated this amount of a contrail, therefore you have to pay this levy. That's the problem that we're going to have to face in the coming months and years. I think much more likely it will just be at least initially, it will be to do with avoidance. So, you know, the contrail, the forming of contrails, I'm no expert, but it's to do with certain aspects of the air and supersaturation of ice crystals from the fuel soot, etc. And it's, I believe, relatively straightforward to just modify your altitude to essentially delete the contrail completely, or delete its formation anyway. So I think it will be much more towards, how do we avoid contrails, especially seeing as they're now coming through as being such a strong component there. Yeah, and an interesting part of the contrail side of things as well is that it seems like actually the aromatic content in fossil fuels, which is, you know, it's a necessary part of any fossil fuel, any aviation fuel, actually has an adverse effect, and the soot causes a nucleation site for the formation of the ice crystals and makes things even worse. And one of the good things about alternative aviation fuels, biofuels, is the aromatic content is much, much lower. I don't know the numbers exactly. And in fact, it was one of the initial problems with alternative fuels was, oh, they've got no aromatics in them. So the aromatics are needed to for the seals within the engine to expand and seal adequately. So that was a problem that I believe has now been overcome by the engine manufacturers. But it looks like alternative fuels might solve that problem potentially. Okay, coming down here. So can you foresee each having a small pollution allowance so that the person with, say, solar and heat pump home heating and uses minimal fuel for road transport can afford to fly? I really like this idea. This is the idea of a quota, essentially, where each person gets a certain amount of, say, carbon dioxide or whatever it might be, or energy, for example, per year, and that's your lot, mate. And you can't go more than that. I like the idea, but I think it probably falls over in practice. Like, there are always, well, here's an example. I'm an aviation enthusiast, so I want to be in a light aircraft as regularly as I can. So I have chosen, I don't know how, by nature or nurture, to like aircraft. And then Joe Blogs Down the Road does not like aircraft, but his hobbies are all low carbon dioxide hobbies. For example, playing the piano. So and there begins to be a sort of an equality component there, and just because I am different, I don't know. I'm getting into dangerous ground of philosophy here, but I think it's the practice of it which is the problem on that one. I think it's the practice. So,
well, thank you very much, Paul. And that's a fascinating idea. And there are all sorts of variants on that that are being put forward. And thank you very much for the talk and for answering these questions. That's been very interesting indeed. We have to wrap up now, so I have to apologize to all those who have asked questions which haven't yet been answered. The presentation will be available shortly after this talk for anybody who would like to re-listen to it or share it with others. And if you've registered for this talk, you will get a link to that shortly. So thank you very much, Paul. Thank you very much, IMechE, for hosting this. We will be having more webinars soon which you'll get to find out about through the normal channels, through the IMechE website or the Sustainability Engineering group. So thank you very much for attending, and I'll look forward to seeing you next time. Cheerio.